Hey, Vsauce, we've all made mistakes. Maybe you did poorly on a test or botched the winning play of a game. Maybe you messed up the introduction to your YouTube video. If only we could go back and change those mistakes. But there's no way we can travel through time. Is there? Hey, Vitus AA, Alexander here. Today we're going to be talking about time travel. Now, time travel has been the focus of thousands of scientific studies throughout the 21st century, but it's much older than that. In fact, time travel can be dated back to the 8th century BC. Hindu mythologies talk about King Raivadakakudmi, who, in an attempt to meet Brahma, left Earth and ventured through the heavens. And while in his mind he was only gone a few days, time back on Earth seemed to have passed much, much faster. And the trend only grew from there. In the 18th and 19th centuries, science fiction writers became obsessed with the idea of changing the inevitable. Time has always been thought of as unchangeable, but these books revolutionized the idea that maybe, just maybe, it's not. Maybe time travel is feasible. And if it is, let's look at how. Well, there are two main theories. The first is wormhole travel. A wormhole is like a shortcut through space-time and has often been described using a piece of paper and a pencil. If you were to take a piece of paper and draw a line between 2 points, you could take time to draw the line between the 2 points. However, if you were to fold the paper in half, lining those 2 points up, and poke a hole through the paper, through the 2 points that you drew, you could instantaneously, or at least very quickly, travel from your first point to your second point. In the same way, wormholes work as the hole poked through the piece of paper. They provide an instantaneous, or almost instantaneous, passage through a bent space-time continuum. So why don't we use wormholes to time travel right now? Well, you see, scientists have yet to actually find a wormhole, but the majority of them still believe they exist. Einstein predicts in his theories of relativity that wormholes are estimated to be about 10 to the negative 33 centimeters, which is about 50,000 times smaller than a hydrogen atom and very unstable. Even if we were to somehow find this minuscule wormhole, it would likely destabilize either before we found it or while a traveler was inside of it. The only way you can stabilize a wormhole is with exotic matter, and that's dangerous for humans, not to mention that wormholes are extremely radioactive. So maybe wormholes aren't the way to go. What about a method that doesn't involve impending death? Cosmic strings. First theorized by Tom Kibble in the 70s, cosmic strings are one-dimensional cracks in space-time. Apparently, there's one in our observable universe. This seems to be something many scientists studying in the field can agree on. But because that observable field is 10 nonillion light years large, that's one with 31 zeros behind it, it only makes sense that our scientists haven't quite tracked down where that is yet. Cosmic strings supposedly weave in and out of our space-time with infinite energy and infinite mass. So, hypothetically, if we were to find two cosmic strings within close enough proximity to one another, space-time would be bent so much that they would create closed time-like curves, paths that people could travel through to end up at any time, any place in the past or the future. So let's say I stumble across one of these quantum cosmic string portals in my stroll through space, and I want to go somewhere in time, whenever, wherever I want. Well, there's a few things that might hold me back. These are time paradoxes, or changes in time that conflict with one another and contradict the laws of physics. The first one of these would be the grandfather paradox. The grandfather paradox states that if we were to go back in time and change an event from occurring, it would alter our future ability to go back in time and alter that event from occurring, either ruining our attempt in the first place, or ruining our chance to returning to a future that's remotely similar to the one we left from. The second paradox is a causal loop. For example, let's say that I did poorly on a test. So what I decided to do, knowing that I had access to time travel, was type out all of the answers for the exam, put it on a USB, and give it to my past self before I took the test. And let's say it worked. I went back in time, handed myself the USB, and passed the test. Well then, all I would have to do is that when I finished the test again, was go, put the answers on a USB again, and give it to my past self, so that my past self could make the USB, and go back in time. The problem is, if I went back in time, after passing the test with the answers, to give myself the USB once more so that I could pass the test again with the correct answers, why would I need to go back in time with the USB? I already passed the test. Why go back a second time and give myself the answers? Well, if I don't go back, will I pass the test? This contradiction is the causal loop paradox. If something happens but requires future action to happen, then the future action can never happen again, or it has to infinitely happen. The Fermi paradox. The Italian physicist Enrico Fermi posed the question, if in the future time travel became a possibility, why wouldn't we have used it to go back and tell ourselves, or to change the past already? Now, there are a few answers to this. The first might be that we invented time travel, but very shortly after died off because of global warming or some other planetary issue. The second is that time travel never ended up existing in the first place, meaning that we could never go back in time and talk to ourselves. But either way, the Fermi paradox assures us that time travel cannot be exacted in the future. So the next time you stub your toe on a table that's sticking out just a little too much in your living room, don't think to yourself, can I go back in time and change that? Think, should I go back in time and change that? Can we go back and change that really quick? I didn't mean to. No, I just keep stuttering. Can we just redo that scene? Yeah, alright. So the next time you stub your toe on that desk that's sticking out just a little too much in the living room, don't think to yourself, can I go back in time and change that? Think about the consequences of those actions, and instead say, should I? Yeah. I think that one's good. Yeah, we'll keep it. Just forget the other one. I'm glad we went back and changed that one because I think this one's better.